December 17, 1941. Mare Island Naval Shipyard, California. Lieutenant Commander Elizabeth Harrington's hands trembled slightly as she reviewed the classified report. 10 days after Pearl Harbor, she held in her hands what could be America's secret weapon against Japanese naval supremacy. The document detailed the newly developed Mark 14 torpedo with its revolutionary magnetic proximity detonator, a weapon the Japanese had no idea existed. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Through eyes reddened from 3 sleepless nights, Harrington stared at the schematics that had just emerged from the Naval Ordnance Laboratory. The Mark 14 torpedo, with its Mark 6 exploder, represented a quantum leap in naval warfare technology. A 2-stage system of such complexity that detecting its capabilities would require capturing intact specimens, something the Japanese never achieved throughout the entire Pacific War. The torpedo contained approximately 507 pounds of Torpex explosive, significantly more powerful than conventional TNT. To Japanese naval officers in their technical bureaus, American torpedoes represented little threat. Their own Type 93 long lance torpedoes had greater range and speed. What they failed to understand was that American innovation had taken a different direction, creating weapons that didn't need to hit directly to be devastatingly effective. Captain Melissa Chen, head of the Navy's proximity fuze section, had personally overseen the Mark 6 exploder's development. In post-war interrogations, Japanese technical officers would admit, "We believed American torpedoes were only contact weapons. The possibility of magnetic influence fusing never occurred to our defensive planners." But the Japanese had made a fatal miscalculation. They had never imagined that the Americans would develop a torpedo that could explode beneath a ship's keel, breaking its back where armor was thinnest and structural integrity most vulnerable. These weapons could sink a ship with a near miss that would register as a complete miss to observers. When the Mark 14 entered full production in 1941, American submarine commanders faced the exciting but daunting prospect of deploying an entirely new weapon system.
They would have to master a technology that promised to revolutionize underwater warfare, but required precise depth-keeping and magnetic calibration. By the morning of December 7, 1941, the Navy had produced enough Mark 14 torpedoes to arm its Pacific submarine fleet, though few commanders had experience with the magnetic exploders. The attack on Pearl Harbor would accelerate deployment of these weapons without the thorough testing they required. The torpedo station at Newport, Rhode Island, occupied what one visitor described as the most impressive military research facility in the Atlantic. The extensive testing ranges and laboratory facilities meant no natural light penetrated to the most secure areas, and air that grew increasingly stale as the day progressed. The constant hum of testing equipment, mixed with the clicking of mechanical calculators, created an atmosphere that newcomers found almost unbearable. Yet Reynolds had assembled here what Admiral King would later call the most valuable weapons development team in naval history. The team was small, roughly 30 personnel at its peak during the early war crisis, but included some of the Navy's most brilliant minds. Lieutenant Commander Olivia Wilson, whose unassuming demeanor belied her mechanical genius, would often work on exploder mechanisms for 48 hours straight, sustained only by coffee and determination. Lieutenant Rebecca Hernandez, whom colleagues called the Wizard for her ability to solve seemingly impossible engineering problems, had narrowly missed being at Pearl Harbor when her transfer orders changed at the last minute. Saved from potential disaster, she channeled her relief into weapons development with an intensity that worried even Reynolds. It was Hernandez who would make the crucial breakthrough in solving the exploder's depth-keeping problems. Working backwards from failed test results, she identified the hydrostatic pressure system that was causing premature detonations. Marine Captain Julia Chen served as chief metallurgist. A material science genius who had graduated top of her class at MIT, she possessed an intuitive understanding of magnetic properties that proved invaluable. Witnesses described her working with protective goggles pushed up on her forehead, welding torch in hand, totally absorbed in modifying torpedo components. Commander Elizabeth Harrington, the mathematical genius behind many crucial breakthroughs, maintained the sign that captured the laboratory's atmosphere. After particularly intense sessions, witnesses described her emerging with hands stained with drafting pencil, eyes bloodshot from peering through oscilloscopes, her gait betraying how close she was to utter exhaustion. By January 1942, this small team had refined the Mark VI exploder enough to begin deploying it throughout the Pacific submarine fleet. Not enough for perfect reliability, but sufficient for what weapons professionals call operational adequacy, functioning well enough under combat conditions to provide a tactical advantage. The most remarkable aspect of the magnetic exploder's development was that it represented technology the Japanese Navy had briefly explored but abandoned as impractical. Japanese naval engineer Fumio Tanaka later admitted, "We conducted tests with magnetic influence fuses in 1934 but concluded the technology was too unreliable. We never imagined the Americans would solve problems we considered insurmountable." The adaptation of magnetic influence technology for naval weapons represented a revolution Japanese anti-submarine warfare doctrine never anticipated. American submarines could now attack from greater distances with higher probability of success. A torpedo passing directly underneath the target's keel would detonate from magnetic influence without physical contact. The breakthrough in magnetic detonation came through systematic experimentation. Reynolds realized that torpedoes behave differently depending on the Earth's magnetic field at different latitudes. Her team created adjustable settings that submarine commanders could configure based on their patrol areas. This human adaptation to natural variation created capabilities Japanese defenses couldn't counter. A single test in February 1942 revealed something extraordinary. When a Mark XIV torpedo was fired at a submerged Hulk target but deliberately set to run deep, it still destroyed the target when passing 5 meters beneath the keel. Hernandez hypothesized this demonstrated the exceptional sensitivity of the magnetic influence detector. Additional tests confirmed her theory. The Mark VI exploder could detect a ship's magnetic signature from significantly greater distances than initially designed. The custom modifications to the Mark VI exploder were remarkable. By spring 1942, the Navy had commissioned special calibration equipment with over 15 different settings designed specifically for different target types and ocean conditions. These settings could fine-tune magnetic sensitivity to distinguish between warships, tankers, and transport vessels. One Navy report noted that calibrating a magnetic exploder for a specific target type took a skilled technician about 3 hours by hand. The new equipment could process the same calibration in under 15 minutes. The investment was staggering for the era. The Navy was spending millions of dollars annually on magnetic exploder research and production. The torpedoes consumed so much of the Navy's precision manufacturing capacity that the Mark XIV program required its own dedicated supply chain. Yet without these weapons, American submarine success in the Pacific would have been significantly diminished. The Imperial Japanese Navy's confidence in their anti-submarine warfare doctrine bordered on absolute faith. Commander Yoshimatsu Hiroki, a senior defensive tactics officer, would testify after the war, "We considered American submarines predictable in their attack patterns. We believed our hydrophone operators would always detect a torpedo launch with sufficient time to evade. What we never considered was that a torpedo could miss our hull entirely and still destroy the vessel." This arrogance permeated Japanese military thinking. The Naval General Staff's technology assessment in 1941 stated that American torpedo development lagged at least 5 years behind Japanese capabilities. They were catastrophically wrong. The U.S. Navy had been systematically advancing torpedo technology since the 1930s, sending officers to study electromagnetic principles and investing heavily in proximity fuse research. The Japanese made another critical error in assuming that torpedo effectiveness rested solely on speed and range. They ignored the fundamental advantage of weapons that didn't require direct hits. Radio operators under pressure couldn't distinguish between different torpedo wake patterns. Tired lookouts couldn't spot periscopes in time. Weather and sea conditions reduced visibility. Each factor provided what torpedo engineers call encounter opportunities, chances for submarines to exploit Japanese defensive blind spots. Even more damaging was the Japanese Navy's institutional rigidity. The same culture that produced unwavering loyalty also prevented critical examination of damage reports. When unusual events occurred, ships seemingly breaking apart without direct torpedo hits, vessels sinking after confirmed misses, naval leadership attributed these anomalies to internal explosions or structural failures rather than unknown American technology. Post-war testimony revealed the depth of this delusion. Admiral Takagi Hiroshi, who had commanded destroyer squadrons, stated, "Even after multiple ships in my group suffered catastrophic damage from what appeared to be near misses, our technical bureau insisted these were coincidental engineering failures or sabotage. They refused to consider that American torpedoes had capabilities beyond our understanding." March 15, 1942, marked a new phase in the submarine war. On that day, the USS Gudgeon, patrolling north of the Japanese home islands, encountered a 9,400-ton transport. When the submarine's first torpedo ran directly under the target without making contact, lookouts on the Japanese ship celebrated what they believed was a miss. Seconds later, the magnetic exploder detonated, breaking the transport's keel and sending it to the bottom in less than 10 minutes. The ship's surviving crew reported to Imperial Navy headquarters that they had been hit by multiple torpedoes, unable to comprehend that a single weapon passing beneath their ship could cause such devastating damage. The debate raged through naval headquarters in Tokyo, with ordnance experts caught between conflicting intelligence assessments. Admiral Yamamoto was increasingly concerned about unexplainable ship losses, but technical bureaus insisted American torpedoes remained inferior to Japanese weapons. Reynolds needed proof of the magnetic exploder's effectiveness. The solution came from submarine patrol reports that included photographed sinkings. In April 1942, she proposed a comprehensive analysis to the Bureau of Ships, using both damage assessments and photographic evidence to demonstrate the magnetic exploder's impact. Using the secure underwater cable connecting the various naval research facilities, they instructed submarine commanders to photograph ships that had been attacked with magnetic exploders, focusing specifically on how they broke apart differently than those hit by contact weapons. The evidence was overwhelming. The trap was set by early May 1942. As Japanese ships continued operating without magnetic countermeasures, American submarines began achieving unprecedented success rates. When submarine commanders understood how to properly deploy the magnetic exploders, their effectiveness nearly doubled. When the Submarine Force Command decoded the patrol reports on May 22nd, the secure facility erupted in celebration. They had not only confirmed the magnetic exploder's effectiveness against multiple ship classes, but also proven beyond doubt that the Japanese remained completely unaware of the technology. The Japanese had fallen victim to their own arrogance, never questioning why their ships were suddenly more vulnerable to submarine attacks. Knowing the enemy's technical blindness was crucial, but submariners needed to optimize their tactics to exploit this advantage fully. The breakthrough came through systematic analysis of patrol reports. Sarah Reynolds noticed that Japanese ships traveling in convoy typically maintained consistent spacing, creating predictable magnetic signatures that could be detected by submarines using passive sonar. By comparing dozens of these reports, Reynolds and Harrington gradually constructed a tactical manual that allowed submarine commanders to target vessels without even needing to visually identify them. On May 24th, the system yielded its ultimate vindication. A message from ComSubPac specified new patrol areas based on magnetic exploder effectiveness against different Japanese ship types. Another intercept confirmed that Japanese anti-submarine warfare doctrine remained unchanged, still defending against direct impact torpedoes only. Elizabeth Harrington, reviewing these reports, made her famous prediction to Admiral Lockwood, commander of Submarine Forces Pacific. "Admiral, the Japanese will continue to lose ships at an accelerating rate through the summer. Their anti-submarine tactics remain focused on evading contact weapons. They will never understand what's hitting them until it's too late." Lockwood studied his ordnance officer carefully before responding. "You're confident in this assessment, Harrington." "Admiral, I'll stake my career on it. The Japanese Navy is operating with a fundamental misconception about our capabilities. Every loss they suffer reinforces incorrect conclusions about why their ships are sinking." On June 4, 1942, while the Battle of Midway raged on the surface, the submarine USS Nautilus approached the Japanese carrier Soryu. When the submarine fired, the torpedo passed directly beneath the carrier. Japanese lookouts reported a miss. Moments later, the magnetic exploder detonated, breaking the carrier's keel at its most vulnerable point. The damage contributed significantly to the carrier's eventual sinking. The crown jewel of the magnetic exploder program came on May 28 with the interception of a Japanese damage assessment report captured from a sinking destroyer. This massive document contained Japanese naval constructors' analysis of recent ship losses, including confusion about why vessels were breaking apart along their keels without direct torpedo hits. The decoded sections revealed staggering detail about Japanese confusion. Their technical bureau had created a special investigation committee to determine why ships were suffering catastrophic structural failures. The committee concluded that American submarines must be using multiple torpedoes against single targets, or that substandard Japanese steel was to blame for the failures. Crucially, intercepts in early June confirmed that despite mounting losses, the Japanese still had not identified the magnetic proximity detonator as the cause. One communication noted, "Examination of damage patterns suggests possible material fatigue rather than enemy action. Ships appeared to break along keel despite confirmed torpedo misses." This revelation that should have prompted immediate countermeasures passed completely unnoticed. No Japanese naval engineer connected the mysterious ship losses to advanced American torpedo technology. The blind spot persisted even as submarine attack success rates climbed dramatically. Other intercepted messages filled in operational details. A June 3 communication revealed proposed convoy defensive changes. Escort vessels will maintain closer proximity to transports as recent losses suggest American submarines are employing deeper-running torpedoes. The Japanese were adapting, but to the wrong threat. Supply chains proved to be the unexpected battlefield where the magnetic exploder's impact was most profound. By August 1942, American submarines equipped with magnetic exploders were targeting Japanese tankers with devastating effectiveness. The Imperial Navy's logistics planners, still unaware of the true cause of their mounting losses, struggled to adapt to what they perceived as a sudden improvement in American submarine tactics. Commander Natalie Wong, skipper of USS Wahoo, received decoded intelligence in September 1942, revealing a major convoy carrying aviation fuel from Borneo to the Philippines. Positioned perfectly by intelligence and armed with the latest Mark VI exploder settings, Wahoo sank 5 tankers in a single night, depriving Japanese aircraft of desperately needed fuel during the Solomon Islands campaign. The statistics were devastating. American submarines, representing less than 2% of Navy personnel, were sinking over 40% of Japanese merchant shipping by late 1942. Much of this success came not from improved tactics or better training, but from magnetic exploders allowing near misses to become catastrophic kills. By late 1942, Japan had lost so many tankers that fuel rationing became necessary even for priority military operations. Flight training was curtailed because aviation fuel was unavailable. Island garrisons faced supply shortages because convoy losses had reached unsustainable levels. The Japanese economy showed initial signs of strain as raw materials stopped flowing. all results of submarines guided by intelligence and armed with weapons the Japanese never understood were being deployed against them. Throughout 1942 and early 1943, evidence of American technological superiority accumulated to levels that should have been impossible for Japanese intelligence to ignore. American submarines consistently sank ships that should have been able to evade conventional torpedoes. Japanese escorts reported torpedoes passing harmlessly beneath targets moments before catastrophic explosions. Damage patterns showed ships breaking along their keel rather than suffering side impacts. Vice Admiral Mikawa Gunichi noted in his official report, "The enemy submarines seem able to sink our vessels despite confirmed reports of torpedo misses. Every convoy suffers losses that cannot be explained by conventional weapons." Yet even this near recognition failed to trigger comprehensive technical investigation. The Japanese did make periodic changes to their convoy protection, introducing zigzag patterns and increased destroyer escorts. Each change temporarily reduced American success rates, but never for more than a few patrol cycles. The fundamental vulnerability to magnetic detonation remained unaddressed, and American submariners had become so proficient they could adjust their tactics rapidly. The Japanese Navy's faith in their understanding of American weapons survived even direct evidence. In November 1942, survivors from the tanker Nishin Maru reported that torpedoes had passed directly beneath their ship without contact, followed immediately by massive explosions that broke the ship's keel in multiple places. Among the survivors was Lieutenant Commander Tanaka Hiroshi, an engineering officer who reported, "The Americans must have weapons that can detonate without contact. There is no other explanation for what we witnessed." His report was dismissed as battle fatigue. Tanaka was reassigned to shore duty and ordered not to discuss his delusions with other officers. The psychological impact on Japanese sailors was profound. Convoy discipline deteriorated as crews realized that evasive maneuvers offered no protection against an invisible threat they couldn't understand. For the women and men who developed the magnetic exploder, victory came with profound moral complexity. They knew their success meant death for thousands of Japanese sailors who were simply serving their country. Every technical improvement translated directly into human casualties. Olivia Wilson, the mechanical engineer, wrote in a private letter, "I calibrated the Mark VI exploder that went into production this month. I certified its sensitivity to detect ships' magnetic signatures at optimal depth. When I signed that approval, I'm signing death warrants for men who will never understand what destroyed their vessel. That knowledge haunts me." The burden was particularly heavy when reports revealed that magnetic exploders had sunk hospital ships or refugee vessels that submarines had targeted by mistake. International law protected such ships, but positive identification often came only through periscope observation that couldn't always distinguish vessel types accurately. The developers faced impossible choices: recommend scaling back magnetic sensitivity and potentially save civilian vessels, but reduce effectiveness against legitimate military targets, or maintain maximum lethality, knowing occasional tragic mistakes would occur. Some messages from submarine commanders revealed Japanese rescue attempts that couldn't be disrupted without exposing the magnetic exploder's existence. Rebecca Hernandez later admitted, "We decoded patrol reports about Japanese ships rescuing survivors. We had to advise submarine commanders to allow these rescues rather than risk exposing our technical advantage. The psychological toll of those decisions was immense." The toll manifested in various ways. Some engineers became obsessed with perfection, terrified that technical flaws might cause weapons to fail when submarine crews needed them the most. Others developed emotional detachment, treating magnetic exploders as abstract puzzles rather than weapon systems. Many struggled with survivor guilt, fighting the war in laboratories while men they armed faced death daily beneath the Pacific. Despite these psychological burdens, the technical teams pushed forward with remarkable innovations. By early 1943, they had developed adjustable sensitivity settings that submarine commanders could configure based on target type. Tankers required different settings than warships due to their different hull designs and magnetic signatures. Transports needed yet another calibration because of their cargo arrangements. The innovation never stopped. In April 1943, Elizabeth Harrington led a breakthrough in countermeasure detection. Japanese ships had begun experimenting with degaussing, reducing their magnetic signature by running electrical cables along their hulls. Without understanding why this might help, they were inadvertently addressing the magnetic exploder threat. Harrington's team developed a modification that could detect even degaussed vessels by sensing the subtle differences between artificial degaussing fields and natural magnetic backgrounds. This kept American submarines one step ahead of Japanese defensive measures. The team also solved the problem of false positives, magnetic anomalies that could trigger premature detonations. By June 1943, torpedoes featured dual validation systems that required both magnetic signature detection and proper depth to trigger, nearly eliminating wasted torpedoes. Perhaps most remarkable was the depth control system developed by Julia Chen. Traditional depth-keeping mechanisms suffered from pressure variations at different operating depths. Chen created a revolutionary pressure-compensating system that maintained precise depth control regardless of operating conditions. This ensured torpedoes ran at the optimal depth for magnetic detection, typically 10 to 15 feet beneath the target's keel. The systematic destruction of Japan's merchant marine through magnetic torpedo technology represents the most devastating impact of this secret weapon. By mid-1943, American submarines were sinking Japanese ships faster than they could be replaced, strangling an island nation dependent on imports. The intelligence advantage was decisive but incomplete without the technological edge. Decoded messages revealed convoy routes and schedules, but only magnetic exploders gave submarines the ability to sink hardened targets with near-certain effectiveness. The Japanese, never suspecting the true nature of their vulnerability, attributed mounting losses to increased submarine numbers rather than revolutionary American technology. Commander Catherine Rivera, skipper of USS Trigger, received a decoded message in October 1943, revealing a convoy carrying critical aircraft parts from Japan to the Philippines. Positioned perfectly by intelligence, Trigger sank 5 ships in 2 days, depriving Japanese air forces of desperately needed replacement components during the critical New Guinea campaign. The statistics by late 1943 were devastating. The magnetic exploder had increased torpedo effectiveness by approximately 45%, according to Bureau of Ordnance assessments. Ships that would have survived near misses with contact weapons were being destroyed by magnetic detonations. The psychological impact on Japanese sailors was equally significant. They could no longer trust their eyes when torpedoes appeared to miss. By early 1944, Japan had lost so many merchant vessels that even basic war materials couldn't reach home islands in sufficient quantities. Steel production declined by 30% due to ore shortages. Aircraft manufacturing fell behind schedule because aluminum shipments were sunk. Food rationing became increasingly severe as fishing fleets were converted to military use, and agricultural imports from conquered territories couldn't reach Japan safely. Throughout 1943 and 1944, evidence of a fundamental technological disadvantage accumulated to levels that should have been impossible for Japanese leadership to ignore. American submarines consistently sank ships despite implementing all recommended evasion tactics. Torpedo wakes passed beneath vessels that subsequently broke apart along their keels rather than suffering side damage. Vice Admiral Toyoda Soemo noted in his fleet assessment, "The enemy submarine force achieves results disproportionate to its numbers. We must consider whether they possess technical advantages we have not identified." Yet even this near recognition failed to trigger the comprehensive investigation needed to identify magnetic proximity detonation as the primary cause. The Japanese did make periodic changes to their anti-submarine warfare doctrine, introducing new convoy formations and increased air cover. Each change temporarily reduced American success rates, but never addressed the fundamental vulnerability to magnetic detonation. The Japanese Navy's failure to identify the magnetic exploder persisted despite mounting evidence. In February 1944, the destroyer Akakais reported observing torpedoes passing harmlessly beneath a tanker they were escorting. followed immediately by the tanker breaking in half despite no visible direct hit. Among the destroyer's officers was Lieutenant Commander Yamamoto Kenji, a naval engineering graduate who reported the damage pattern suggests underwater detonation without direct contact. The Americans must have developed influence fusing technology. His report reached naval headquarters but was filed without action. The institutional blindness was so profound that even when presented with the correct technical explanation, Japanese leadership couldn't integrate it into their understanding of the war. This failure of imagination cost them dearly as American submarines continued exploiting a vulnerability the Japanese refused to recognize. For the engineering teams who developed and refined the magnetic exploder, victory brought both pride and deep ethical questions. Sarah Reynolds would later reflect, "We created a weapon that the enemy never understood was being used against them." The moral complexity of that achievement is something I still struggle with decades later. Did our technical secrecy save lives by shortening the war, or did it merely make killing more efficient? Despite operational neglect and bureaucratic obstacles, history has vindicated the magnetic exploder's achievement. Admiral Chester Nimitz stated unequivocally, "The submarine force's success against Japanese shipping combined the advantages of superior intelligence, determined crews, and revolutionary weapons technology. Without the magnetic exploder, the strangulation of Japan's maritime lifelines would have taken significantly longer." Even Japanese military historians eventually acknowledged the decisive impact. Professor Watanabe Tetsuo of the Japanese Defense University wrote, "The American magnetic proximity fuse represented technology Japan had considered but abandoned as impractical. Throughout the war, we were fighting an enemy with capabilities we failed to recognize even when the evidence was before us." The true measure of the magnetic exploder's success lies not in battles won but in ships sunk without the Japanese ever understanding how they were being destroyed. This technological deception allowed American submarines to maintain their advantage throughout the entire war, with the Japanese never developing effective countermeasures because they never correctly identified the threat. Yet recognition of this technological achievement came slowly for those involved. Reynolds' team was gradually disbanded as the war progressed, with members reassigned to other projects deemed more critical as the strategic situation evolved. Their work remained classified for decades, preventing public acknowledgement of their contributions. The revelation of American magnetic exploder technology shocked Japanese naval officers more than almost any other aspect of defeat. During post-war interrogations, many refused to believe the claims until shown actual technical documents and torpedo schematics. The psychological impact was devastating. They had been fighting an enemy with technology they had dismissed as theoretically impossible. Admiral Toyota, who had served as Combined Fleet Commander, stated during his 1949 interrogation, "If we had known you were employing magnetic influence fuses, we could have developed countermeasures. Degaussing techniques existed that might have neutralized your advantage. We were fighting an invisible weapon because we refused to see what was before us." Captain Ito Masanori, who had headed the Naval Technical Division, was even more direct. "Our failure to detect your magnetic proximity detonator technology was inexcusable. The evidence was present in every damage assessment, ships breaking along their keels despite torpedoes passing beneath them. We attributed everything to structural failures and refused to consider technological explanations." The revelation triggered soul-searching that continued in Japanese naval engineering circles for decades. How could a naval power that prided itself on technical excellence fail so completely to identify an enemy technological advantage? The answer lay in institutional arrogance, rigid thinking, and the isolation of technical bureaus from operational reality. The Japanese had never understood the revolution that electromagnetic influence fusing represented. While they focused on torpedo speed and range, Americans were developing weapons that didn't need to hit their targets directly. The technological blind spot was profound. One side fighting with outdated understanding, while the other exploited a fundamental advantage. The magnetic exploder established principles that guide naval weapons development to this day. The operation demonstrated that technological secrecy can be maintained even when a weapon is used extensively in combat. It proved that enemies will construct explanations that fit their existing worldview, rather than acknowledge fundamental challenges to their understanding. The collaboration model developed for the magnetic exploder, combining research laboratories, field testing, and operational feedback, became the template for modern weapons development. The systematic refinement process, with technical teams responding to battlefield experience, established patterns still followed by defense contractors today. The ethical frameworks developed by Reynolds and her team still influence weapons development. The principle of creating systems that maximize effectiveness while allowing for discrimination between legitimate and protected targets remains paramount. The integration of weapons technology with operational planning, pioneered by submarine commanders using magnetic exploders, is now standard military doctrine. Most importantly, the magnetic exploder demonstrated that technological superiority can overcome numerical disadvantage. In 1942, the Japanese Navy was superior in numbers, experience, and many aspects of naval technology. Yet American submarines negated these advantages, enabling an initially inferior force to achieve decisive victory through superior weapons technology. Despite its catastrophic impact on Japanese shipping, the magnetic exploder's success offers warnings that remain relevant. The same overconfidence that blinded Japanese engineers to American technological innovation appears in every era's assessment of its own technical superiority. Today's impossible weapons may be tomorrow's reality for adversaries willing to challenge conventional thinking. The Japanese Navy's compartmentalization, which prevented comprehensive technical assessment, mirrors modern bureaucratic divisions that inhibit effective technology evaluation. The human factors that prevented recognition of the magnetic exploder, institutional pride, confirmation bias, and resistance to acknowledging fundamental threats, remain primary vulnerabilities in contemporary military organizations. Most sobering is the psychological dimension. The Japanese Navy couldn't conceive that American torpedo technology had leapfrogged their understanding because such a possibility challenged fundamental assumptions about Japanese technical superiority. Similar blind spots exist in every nation's defense establishment. Technologies deemed impossible that become achievable through innovative approaches. Modern navies study the magnetic exploder case as both technological achievement and cautionary tale, yet often miss its most important lesson. The enemy you underestimate technologically is most likely to defeat you. The American engineers in their secure laboratories, dismissed by Japanese intelligence as incapable of developing influence fusing, systematically destroyed the Imperial Navy through electromagnetic physics and innovative engineering. In 1985, surviving members of the original magnetic exploder development team held their first and only reunion in San Diego. Fewer than 15 attended. Age, distance, and death had claimed most of the original team. They gathered not as celebrated heroes, but as elderly women and men whose greatest achievement remained largely unknown to the public. Elizabeth Harrington, then 83, gave the keynote address. "We were engineers and physicists, not warriors. We fought our war with slide rules and oscilloscopes, not guns and bombs. Yet we sank more Japanese ships than any naval task force, saved more American lives than any medical unit. We were invisible then and remain largely invisible now." Rebecca Hernandez, who had overcome her wartime trauma to become a prominent engineering professor, added, "Every magnetic exploder we perfected represented lives. Japanese sailors who would die, American submariners who would survive. We celebrated technical successes knowing they meant death for enemies who never understood what destroyed them. That burden never leaves you." The reunion's most poignant moment came when the group raised a toast to Sarah Reynolds, who had passed away 3 years earlier. Her daughter accepted a commemorative plaque that had been carried aboard the USS Nautilus during its historic nuclear-powered circumnavigation beneath the polar ice cap. The accompanying citation read simply, "To the woman who made victory possible through innovative thinking when convention failed." The magnitude of the magnetic exploder's achievement can be measured in stark statistics, revealing both operational scale and decisive impact. By December 1942, approximately 60% of American torpedo attacks benefited from magnetic proximity detonation. By war's end, that figure had risen to over 85% as refinements made the technology increasingly reliable. Operational impact was enormous. The submarine campaign sank 1,113 Japanese merchant vessels. Overall tonnage loss reached 55% of Japan's pre-war merchant fleet. An estimated 60% of these vessels were destroyed by magnetic detonation rather than direct hits. Lives saved included countless American submariners who could attack from safer distances and positions. The Japanese intelligence failure was total. 0 successful identifications of magnetic proximity detonation technology throughout the entire war. Multiple incidents that should have triggered technical investigation were ignored or misinterpreted. No comprehensive research into unexplained damage patterns was ever completed. Post-war, many officers still refused to believe proximity fuses had been deployed against them. The battle between weapon developers and naval architects in the Pacific represented an early example of technological warfare defining future conflicts. While the Japanese relied on conventional torpedo doctrine and traditional anti-submarine tactics, the Americans deployed revolutionary proximity detonation technology. The magnetic exploders could cause catastrophic damage without direct hits, making conventional evasion tactics obsolete. Custom modifications allowed submarines to sink targets that should have been safe from conventional weapons. The Japanese continued believing their anti-submarine doctrine was fundamentally obsolete against American technological innovation. This blindness, rooted in arrogance and institutional failure, accelerated Japan's defeat. The Americans who developed the magnetic exploder
received little recognition in their lifetimes. Reynolds was professionally marginalized after the war as defense priorities shifted. Her team was dispersed and silenced by classification. Their achievement remained largely unknown for decades. Yet their invisible victory was perhaps the most decisive in the Pacific War's battle for maritime supremacy. Today, in an age of advanced proximity sensors and sophisticated naval weapons, the lessons of the magnetic exploder remain relevant. No defensive doctrine is immune to technological disruption. No system remains perfectly secure when innovative thinking challenges fundamental assumptions. The same institutional blindness that prevented Japan from recognizing proximity detonation threatens every organization convinced of its own technical superiority. The secure laboratory where the magnetic exploder was perfected is now a storage facility, its testing equipment long dismantled, its heroes mostly forgotten. But their legacy endures in every naval weapon, every proximity sensor, every influence fuse developed since. They proved that wars can be won through patience, brilliance, and the methodical application of scientific principles against enemies blind to their own vulnerabilities. The Japanese never knew American torpedoes had magnetic proximity detonators. That ignorance cost them their merchant marine, their supply chains, and ultimately their war. In the history of technological failures, none was more complete or preventable than Japan's blind faith in conventional anti-submarine doctrine, while American torpedoes exploited a vulnerability they refused to acknowledge existed. Their story reminds us that in warfare, the most dangerous enemy is not the one who matches your strength, but the one who renders your defenses irrelevant through innovation you fail to recognize. The Imperial Japanese Navy learned this lesson too late, discovering only after surrender that throughout the war, American magnetic exploders had been destroying their ships without direct contact, directing their defeat and ensuring that Japan's maritime power would never recover from a technological advantage they never understood was being deployed against them. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.